Right, today we're going to briefly look at the graph of a function and that of its inverse. There's a kind of a special relationship which exists there, which we want to highlight. Right, I think let's take a simple function similar to the one or same as the one we did yesterday. We looked at y equals to 2x plus 1. That's all. So y equals 2x plus 1. Now we say to find its inverse. Let's say this is f of x. You remember yesterday we said to find now f of x inverse. Second function, f of x. We said we're going to take the input to be the output and the output to be the input, isn't it? And after dealing with this thing, I think we ended up with what? Half x, isn't it? Plus, was it plus or minus half? Minus half. So, remember the calculation, the manipulation of this thing to get to this equation. We already discussed. I'm not going to repeat it here. I'm just going to use it. Was what I want to focus on now is the graph instead of the how to get that inverse. All together. Now let's sort of, you don't put a short ruler here, a 15 millimeter ruler, 15 centimeter ruler. No one. Okay, look, I'm going to try to use my free hand here. Let's use my free hand. Then let's start. Oh, thanks. Why are you so cruel? Okay. Right. 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 I hope this is going to work fine. I want just to draw a kind of a straight line here. Okay. Right. Right. Let's see. We said this line, the first line, was cutting the y-axis at 1, isn't it? And let's say we've got 1 also here. And when y was 0, when x was 0, sorry, when y was 0, x was minus half, isn't it? Then we said if 1 is here, minus half is somewhere there. So that's minus half. So our line I think I'm going to draw this line freehand because our line was going more or less like that. Is that so? Then the other line, when we plotted this line, isn't it? When we plotted this line, we find out that it was crossing at, let me just say, undo that. And let's do this. I think it's much better. Eh? The other one was cutting where? At minus half here, because that's the intercept, isn't it? And the other one was 1. Then the lines were going this way. Please guys, I want you to go home and attempt to do this thing on a graph piece of paper, just to have a feel of what I'm going to say here. That's right. So these lines, they cut somewhere at a point there. But when you look at that, remember yesterday we talked about an identity. A function like this, f of x equals to x, is an identity function, isn't it? Yes or no? It takes x and takes out x, isn't it? That's what we said yesterday. So which means then, this is actually the line y is equals to x. Do you know where that line is? That line passes through the origin here and bisects the two angles, isn't it? The first and that. We all know that, isn't it? So now let's try to get a color for that line. Let's try to get a color for that line. That line will go this way. And that is y is equals to x. And this side it will go through this way. And it's definitely going to pass through the cutting point there and go that way. Altogether, what do I want to emphasize about these two graphs? A function and its inverse. This is f of x. Sorry, this is f of x to the second function, which is half x minus half. And the other one, this one is y equals to 2x plus 1. We showed that if we compose this function, you get an identity, isn't it? So in other words, actually, when you compose these two functions, you actually get y is equal to x, which is 10.2. Now, one thing which I'm going to highlight, which is important, you should never forget while you're doing mathematics, is that if you plot a function and the graph, if you plot the graph of a function and that of its inverse, they are always going to be symmetric around y is equal to x. Now, one line becomes the mirror image of the other. I think you remember in physics, when you do this experiment about the distance of the object to the mirror and the image to the mirror, you actually establish that if this is the object, this one is an object, the distance here is exactly the same distance as the distance there, altogether. So now the two lines make a symmetric body around y is equal to x. And that's a general thing. That happens with all graphs of functions when they're compared with the graphs of their inverse. Altogether. So what can I do? I can actually give you an exercise. I can just give you an exercise more or less like this. Draw a function. Like for example, I can draw a function like this and tell you that it's a function. And then say, guys, insert the graph of the inverse without knowing what is the function. That's what I'm saying. Say insert the graph. All what you need to do, you need exactly to use what I'm saying now. You will have to insert the identity function graph. Then after that, what you do? You just, each of the points on this graph, try to find the mirror image across the identity function. Then you just join those points. Then you got the thing. Is that right? That is something which you must know. I don't know. Did you discuss that at school? You did that? Yeah. So that's very important also. Yeah, you must remember that. You must forget that. Okay. So I think I'm going to stop there. But maybe let me just get another function which you can try to get it inverse, isn't it? Just to have an example. Let's say clear that. Let's say find. Oh, sorry. Oh, find the inverse of the inverse of the following function. Right. Let's say we're given here a function like y equal. Let's look at a function where we're involving a square root sign, and looking at, in this case, a principal square root. Let's say we put y equals to 3x plus 1. I'm just giving another example how to find inverse. For polynomials, it's very easy. Functions are a bit difficult. Is transcendental functions like the sines, the what, They're not like you can manipulate like these kind of expressions of x. Now we say it now. We're going to make x our input, we make it our output. Then our output make it that. Now just check how am I using that? I'm using this as a tool, not really. Maybe some lecturer will not say it this way, but basically to me it turns out to be, it's going to be, will end up to the same thing. So what do you do? I go back to the expression given there and just swap these things around. Isn't it? So what I'm going to do here, I'm going to have x here equals to square root of 3y plus 1. Isn't it? Because of the convention that our functions are always y equals to some expression of x. So in this case here, we now need to put y as a subject of the formula. Once we achieve that, we've got the inverse. All together? Okay. So then what we're going to do now here? What do we need to do? Square both sides, isn't it? Now, if the operation square, you must see it as an inverse operation to square rooting. All together? It reverses the operation, isn't it? Okay. So then if we square both sides, we're going to have x squared equals to 3y plus 1. All together. Then in this case now, we're going to have 3y equals to x squared. In this case, let's add on both sides minus 1, or let's subtract minus 1 on both sides. The same thing, isn't it? So if we get that, we're going to get 0 here, which is added to 3y is 3y, and this side we're going to have minus 1. All together. Remember what I said yesterday, nothing moves and changes sign. All together. Okay. So then after that, y is equals to x squared over what? Over 3 minus 1 over 3. Right? All together. Okay. So if we let's take a number here, let's take just to show that this is an inverse. It must be able that when we compose the function, we must compose the two functions. We must get an inverse and identity. You understand what I'm saying? If you compose the function, you must get inverse. So now this is let's call this g of x. Let's then compose. Let's find the h of x, which is the composition of f of x, g of composite of f of x and g of x. Isn't it? What I'm going to do? This g of x is going to be the argument of f of x. Isn't it? Where is our f of x? Is here, isn't it? Okay. So then we want to see whether we're going to get something like h of x is equal to x, which means that is an identity function, isn't it? Okay. So now what we're going to do here, we're going to say apply f says square root of. Now we put g there, inside there. What are we going to put there? We're going to put 3 brackets, wherever x is, we're going to put g, isn't it? What is g? G is x squared over 3 minus 1 over 3 close, isn't it? And then plus 1. All together, guys. Is everyone following that? Yeah. We're plugging g in the place of x because g is now the argument of our function. So that's that. Now let's play around with this. If we play around with this, we're going to get this times what? Times 3, which is going to be x squared, isn't it? And then this times 3 is going to be 1. So we're going to end up there with something like x squared minus 1 in brackets plus 1 altogether. Then simplifying that, we're going to get square root of x squared, isn't it? then what is that? X. You see that h of x equals to x. Altogether. So I think it's confirmed what you said yourself. Whenever you compose a function with its inverse, you get an identity. So what I want you to do now, I want you to maybe go home and do this one yourself. Exactly the same function. Do this composition. G of f of x, and check if you are going to get, I'll put a question mark there to see if you are going to get x identity function. Altogether, just manipulate the thing, push the pen against the paper, and see that you arrive at that type of expression. Are we there, guys? Okay. So I think as far as the concept of a function, the inverse, the composition of function, I think it's now must be sitting comfortable with you. The next thing what you must do is to practice different expressions and see what basically it's an algebraic manipulation of this thing until you get it right. Are we together? All right. Let's stop there. Thank you for listening for that part.